I'd like to do an overview of the graphing of quadratic functions by shifting, stretching, and reflecting. And one thing to remember is that quadratic functions or quadratic equations are second degree. So we see this equation here, y is equal to ax squared, so we've got a squared term, a linear or first power term, and then a constant. And these equations are going to always have the shape of a parabola. And some of the important landmarks are the direction of opening. For example, does it open face up or does it open face down? Another important landmark is the vertex and the axis of symmetry. So where does this parabola sit and where is its vertex or turnaround point in relation to the x and y axes? And then through that vertex we can draw the axis of symmetry, which will then show us where it reflects left and right. And the third important landmark is the width of the parabola. So it's possible for two parabolas to have the same vertex. So I'm going to draw another vertex here, and that they would have then the same axis of symmetry, and they can even both be, in this case, face down, but they're different parabolas because one is wider than the other. So for linear equations or straight lines, we only need two features, the slope and the y-intercept, to determine the line. But for quadratic, that is second degree equations, we need to have three features. So we're going to take a look at creating different parabolas using various features, and two of the features that are described here are stretching and reflecting. And what we're going to do is learn how to modify what I call the basic parabola, which is f of x equals x squared. Calculate the points by plugging different values of x into the equation. And so when we take a negative 2 and square it, we get positive 4. Take negative 1, square that, you get positive 1. 0 squared is 0, 1 squared is positive 1, and positive 2 squared again is 4. And we can plot these points. So the first one is negative 2 in the x direction, positive 4 in the y direction. And the second point is negative 1, positive 1. We have a point at 0, 0, positive 1, and positive 2, positive 4. And so we can draw the basic parabola through these points. And we have something that looks like this. If we wanted, for example, to triple the height, and so here we have g of x is equal to 3 times x squared, so that coefficient will triple the y value or the height of that graph, then we can also draw a parabola in the same way. And rather than recalculating everything, I can just take this y value, and again, because it's 3 times the previous, I'm going to triple that, and so 3 times 4 gives me 12, and 3 times 1 gives me 3, and 3 times 0 is 0, and 3 times 3 is 3, and then 3 times 4 again gives me 12. So now I can graph the points, and this is going to result in a much taller parabola. So at negative 2, positive 12, we're actually off the graph somewhere. But at negative 1, 3, we're over here. 0, 0 is the same point at the origin. 1, 3 is over here. And finally, the point 2, positive 12, is, again, off the graph. And if we were to draw this parabola, it would look something like this. So we have a much narrower parabola. We can also multiply by a coefficient that's a fraction, in this case a half. And what that does is it takes all of our vertical values or our y values and divides them by 2. So if we take the y value for f of x and we cut that in half, we end up with positive 2, and then 1 divided by 2 or multiplied by a half gives us a half. And then 0 times a half is still 0. And then positive 1 times a half again is a half. And finally, 4 times a half gives us 2. Plotting these points at negative 2, positive 2, then negative 1, positive a half, 0, 0, the origin again, positive 1, positive a half, and positive 2, positive 2. And connecting these dots, we can see that we would have a wider parabola. The last transformation I'd like to do is multiplying by a negative number. So again, we're going to take our y values here and just multiply by negative 1. So we get negative 4. Negative 1 times negative 1 is negative 1, 0. And then negative 1 times this positive 1 will still give a negative 1. And negative 1 times 4 gives us negative 4. And plotting these points, in the negative x direction we've got negative 2, but this time negative 4. We have the point negative 1, negative 1. Again, the origin at 0, 0. When x is positive 1, y is negative 1. And when x is positive 2, y is back at negative 4. And now when we plot this one, it looks upside down. So you can see that whenever we have a positive coefficient, we're going to end up with a face-up parabola, and whenever we've got negative coefficients, we'll end up with face-down parabolas. And we call the valley, or the bottom, of a face-up parabola the minimum, and we call the peak, or the top of the face-down parabola, we call that a maximum.